Login accepted.
Welcome everyone. I'm glad that you decided to see a security talk. My name is Tomasz Wrobel. I'm working for Raseco Poland. I'm a security-minded developer. So let's start with what's new and not so new in the new OWASP Top 10. Just quick reminder, OWASP is a non-profit organization that aims to improve security in software. And it's mostly famous for the report that issues every 4 years with top 10 security risks. Let's start with the changelog. This is the comparison between the report from 2013 versus 2017, so the last two reports. What you can see is that there's not too many changes. 8 out of 10 risks were carried over to the new report, and only 2 have been dropped. If we look at the current report versus the previous report, the current report which was issued last September, it's actually even worse, because all of the categories from 2017 have been carried over to the current report. Only some were merged just to make space for new categories. And what does it tell us? In my opinion, it tells us that we, the IT people, are failing. 4 years in IT, it's a lot of time. We change technologies, we change the software development overall, yet we still have the same mistakes. And it doesn't happen only in legacy systems. We see those mistakes in the new application also. This is the site that tracks JOT tokens used with algorithm none for signature. As you can see, there are new apps here that has this problem. Yet we know this problem for over 6 years. So another thing I want to mention is a lot of IT services or cloud providers offers their security services. Here's the list from Google Cloud with number of different services and tick box against each risk from OWASP Top 10. As you can see, the list is pretty long. It's definitely worth to use those services, but we cannot really rely on them only for security, because we should take castle approach, also called defend in depth. Like in medieval castles, we should apply number of different security defenses. Like in castles, they had moats, towers, walls, etc. In IT, in our applications, there should be security incorporated in servers, load balancers, web application firewalls, application themselves, headers for web browsers if it's a web application. Let's also have a look at development. It doesn't matter if you use Agile or Waterfall. Usually, security test happens on the very end of the process, just before the application is released and deployed. Also, nowadays, development is pretty fast, and security guys has trouble to catch up with the development. Another thing, when the application is nearly ready, well, our application live, we got new features, we've got fixes, maintenance, etc. And this comes back to the design, into the coding, into the testing, and then into our application. But with this, then just before the release, we think, oh, security. And the security guy is in trouble because he doesn't know what and when to retest for security. There's a concept of moving security left on that diagram. So from the very end, just before the release, just to test phase, the implementation phase, and design phase. That's a great idea, because if problems in regards of security are found early, it's just much cheaper and much faster to fix them. But in my opinion, it shouldn't be called shifting left. I would say shift everywhere. Also think of security once you pass that step, when you go about the release application, when you're releasing the application, when you're deploying application. etc. So let's come back to the OWASP Top 10. So what is actually new in that report? If you look at the list again, and we take out the stuff which was carried over from the previous report, we are left with three things. First of all, insecure design. The name sounds vague, but in my opinion, it's very important stuff. It's probably the most important of the new things, and I want to explore it on the next slides. Next one is software and data integrity failures. It's basically extended insecure deserialization from the previous report with few additions. And one of them is software integrity. When you take the package from a repository and you bring it into your own code, you set the version of this package. But also, what you should use, there is an option to use a hash of that package, making sure that this version of the package that you take into your application is not only with the same version, but it's exactly the same build. And we know many attacks on the supply chains. So with npm, when you've got your package log file, you've got the integrity hash. If you use npm clean install, npm CI on your CI tool that's building the deploy, this hash is actually checked. Otherwise, if you just use npm install, it isn't checked. And the last new thing in the OWASP Top 10 is the server-side request forgery. It's an attack when attacker takes the malicious payload and attacks a server that is publicly available but has a vulnerability. And through that vulnerability, with his payload, he can attack the internal network. So the vector of the attack is actually internal network that is not publicly available, but he's able to attack it through this public server with a vulnerability. So as I said, insecure design. Let's explore it. It's a revolution, really, because until then, until this report was issued, OWASP Top 10 report only included really risks, and insecure design is actually not a risk. Let's see some examples just to explain it, maybe easier. Validation on the client end only. It's great for UX, but it's nothing to do with the real validation with security. Another example, authentication. Storing passwords in irrecoverable formats, or security questions in forgotten password. We shouldn't use them anymore. Sensitive data in query strings, like in get parameters, or error messages containing sensitive information. So as you can see, those problems, even if implementation is correct, it is a problem. But the problem is not with the implementation itself. Just the design, the idea is wrong. What are security design principles? Few quotes from the report. It's not an add-on or a tool you can add to your application. It's a culture and methodology that constantly evaluates threats. And it ensures that the code is robustly designed and tested against known attack methods. How to prevent insecure design? So first of all, it would be a great idea to use secure software development lifecycle to evaluate design and security. Yet, it's very hard to do because you would need security guys at every step of your software lifecycle. Use threat modeling, especially for critical processes. In my opinion, that should be done in every project. Use reliable components and frameworks. There's no point to reinvent the wheel. Use something which is proven, which is tested, which gets upgrades. And unit test and integration test for security. With well-known test-driven development, I hope you use them. Yet it's not too common to write tests for security. Just before COVID, I've been at a conference, and there was a guy from Google. They had a problem with sanitizer. Somebody found the problem in their sanitizer. The guy from Google fixed it, and then a year later, he see the same problem. Somebody reported this through their bug bounty. He couldn't believe it. He looked at the code, and somebody just through the over the months, somebody just removed his fixed, and he just thought, if I only wrote a simple unit test that wouldn't happen because the test will go red. So think of writing tests for security flaws, not just for features. I mentioned threat modeling. So what really is it? A quote from the threat modeling manifesto. Threat modeling is analyzing representation of a system to highlight concerns about security and privacy. And the main thing about threat modeling is answering on 4 questions. What do we do? What can go wrong? What do we do with the thing if something goes wrong? And is this what we do? Is it good enough? To analyze software, you need a representation or a model of some sort, like a diagram. So what do? All you need is to do diagrams of your critical processes. And then for each of those diagrams of the critical processes, you need to take them and have a look at them closely. Like in here, if you've got a roadrunner running, and you've got the coyote above your head on a wire with a heavy anvil, and he wants to throw it at you to kill you, you know it's not good idea, it's a common sense. In IT, for threat modeling, we use common sense and our experience, but not only that. What we can use is threat modeling methodologies, and there's plenty of them. I just want to show you 2 of them. Both are mnemonics. One is DREAD, which is potential damage, so how bad could it be? Reproducibility, so how easy to reproduce the attack. Exploitability, so knowledge and tools needed for the attacker. How many users can be affected? And how easy for attacker to discover that that attack is possible. Another method is STRIDE, which is spoofing, so pretending to be someone else. Tampering, so changing data. Repudiation, so denying that some action took place. Information disclosure. Denial of service, so making system unavailable. And the last one is elevation of privileges. And when you think of elevation of privileges, don't only think of the standard vertical elevation, so from user to admin. We also need to think of vertical elevation, so from user A to user B. So user A, if user A is being able to do a action on behalf of user B, that's usually it's not good. An example. So we take STRIDE to model. We take a story, so forgotten password on a website. So I imagine that when you got forgotten password, you click it, you got the input, you put your email, and you get a link to reset your password to your email. So we need to ask 6 questions from STRIDE. Spoofing. So I imagine the email you get. In email you get a link, and a link could look something like this. So the domain, forgotten password, /number, maybe user ID. If it's a user ID, it's easy to guess. Not a good idea, definitely we have a risk there. If it's followed by some other number, that's better, but if this is incremental number, again, it's still easy to guess. And somebody else can just guess the link and reset somebody else's password. If it's a hash, that's better. But the question is, if this is strong hash, if this is cryptographic safe hash. So I would say yes, there is a risk of spoofing. We need to consider there is a risk of spoofing. Tampering data, not really. Repudiation, we log an event that somebody wants to reset the password. It cannot be deleted really, so no repudiation possible. Information disclosure, well, I would say yes, if we confirm after you put your email that yes, we send you the email, or no, this user doesn't exist. But this is disclosure information. We tell that this email is registered in the system. And in my opinion, we just shouldn't do it. Denial of service. Well, if we use strong rate limiting, somebody tried to brute force the forgotten password input. So he sent many hits to the system, and the system could go down if it's not, if it doesn't have a strong rate limiting. And elevation of privileges, well, no, not really. That means that the STRIDE score is 3 because we got 3 yeses. So what do you do with that? So you take all your critical processes, you identify them, you put them through Stride, through Dread, or any other method that fits you, and you rank them. And then you take from the top the highest ranks, and you analyze them, and you decide if this what we're doing is good enough, or we should mitigate it, we should change something, we should do something about it, we should talk to our business maybe about it, if they accept the risk. So just to wrap up this talk. Application security depends on all of us. Don't blame just security tester for security. Be aware of risks and constantly improve your security awareness. Think of potential risks. We, developers, knows the best what's inside our applications. Not the security guys, really. If you liked the talk, please vote in your applications. If you didn't like it, don't vote. Thank you. I see I've got 1 minute left. If there are any questions, I can take them now, or I'll be around today and tomorrow. You can catch me. Okay, no questions? Thank you. Enjoy the conference.